Hi, my name is Alejandro Castillo Estrada. I'm a student from Universidad de las Américas Puebla, and I'm going to present my Abet project for the subject of free energy balances. So the problem description. The project consists of predict and develop a isotropic binary mixture for ethanol and toluene at 55 Celsius degrees using Margoul's thermodynamic activity model for the Gibbs free energy. So I checked the periodic tables that I was provided with pressure and compositions by using these equations with my solution proposal, with are basically Antoine equation, Gibbs energy equation, and Margoul's equation for activity coefficient, and also the Raoult modified law. So first of all, I use Antoine to predict both saturation pressures, and I use a graphic method to predict the A12 and A21 to predict the activity coefficients, but then I corrected by a solver in Excel, and I finally got my activity coefficients which was gamma 1 and gamma 2, and then by Raoult modified law I finally got my compositions x1, y1, x2 and y2, and I check it by adding x1 and x2 and y1 and y2 and looking for the total sum to be 1, so or close to 1. And in my resume table, I graphic x1 and y1 with pressure with my theoretic pressure and the experimental data, and compare them. So we can see that it changed a little, but also we have to analyze that it's historical data, and it cannot be as exact as the experimental one. So finally, the use of the current or emerging technologies. Basically, I use Excel to do my project, but it can use other simulators as Aspen. My principal source of information was YouTube. I also use a lot of the ebook of thermodynamical chemical engineering. So I think that it's very important to be actualized and also being constantly informed to have the best tools at our disposal. It is impressive to see how a series of complex calculations takes only a few hours if they know how to use them correctly and generate a positive change in our experience as future engineers. Perspective and reflection. So, in the dynamic realm of chemical engineering, applying established knowledge is essential, but true progress and innovation lie in adaptability to new and emerging technologies. This path to excellence requires not only technical skills, but also critical thinking rooted in an understanding of technological change. In the constant pursuit of efficiency and improvement, it is crucial to maintain a solid awareness of existing gaps, identifying areas where current information and practices may become obsolete. Simultaneously, a consciousness of growth propels the exploration of new frontiers. The quest for innovative information and the implementation of advanced models backed by the latest emerging technology in the chemical engineering project. This combination of applying knowledge, adapting to new technologies, exercising critical thinking, maintaining gap awareness, and fostering growth awareness not only ensures success, but also establishes the groundwork for a meaningful contribution to the ongoing progress of the discipline.